Good afternoon, everyone. Welcome to Symbiosis School for Online Digital Learning. This is our subject Lean Six Sigma, and today we are going to discuss Introduction to Lean Six Sigma and Initiating Lean Six Sigma, that is related to Module 1 and Module 2. This is session number 1, dated 9th March, and time duration will be 4:10 to 6:10 p.m. Myself, Dr. Sandeep Sharda, will be taking this session today, Introduction to Lean Six Sigma and Initiating Lean Six Sigma with the Module 1 and Module 2 perspective. This is my self-introduction, which is already been discussed. However, just to know, to acquaint you, this I have done my BTech in 1988 in mechanical, and later on I was there for the 16 years in the industry. And after 2006 onwards, I did my MBA and PhD in inventory spare parts management. And since 2006 onwards, I am with academic and mechanical as well as the management teaching. And from 2022 November onwards, I am with the Symbiosis Institute of Operations Management and simultaneously engaged with the Symbiosis School of Distance Learning, specifically for the operations management and supply chain management subjects. So major content for the Lean Six Sigma topics are Introduction to Lean Six Sigma, value proposition to stakeholder, culture of Six Sigma and lean production tools. These are the major area as far as the Introduction to Lean Six Sigma is concerned. We are going to discuss the evolution of the lean, evolution of the Six Sigma, what is Lean Six Sigma, how it is being corresponding to the industry and how it is putting an impact on the in the industry in manufacturing as well as service sector to provide the value proposition to the stakeholders and the customers as well. Initiating the Lean Six Sigma, we'll also discuss what will be the top management commitment as far as Lean Six Sigma is concerned. If you are going to implement the Lean Six Sigma into the industry, company-wide vision, infrastructure and development planning, and the right people for the right project. That how we are going to initiate the Lean Six Sigma into the industry sector, whether it is a manufacturing or service industry. A dynamic improvement process, that is we are going to discuss how the sequence of process for the initiating Lean Six Sigma with the examples it is going to be carried out. The dynamic improvement tools leveraging Lean Six Sigma in SCM acceleration, Lean Six Sigma logistics 1.5, design for Six Sigma. These are the total 7 modules we are going to discuss today. Perspective to the module 1 and module 2, introduction to Lean Six Sigma and initiating the Lean Six Sigma. As far as the overall learning objective and recommended books are concerned for the Lean Six Sigma, to apply the concept of the Lean Six Sigma to manufacturing and the service organizations, to demonstrate the how quality initiative of the Lean Six Sigma can be integrated, and uh, to illustrate step-by-step roadmap for planning and implementing the Lean Six Sigma projects, to design and develop, to design and develop a Lean Six Sigma approach for the company to achieve the performance excellence, to design an approach of the Lean Six Sigma for the supply chain network. Just making the point up. Okay. Now coming to as far as the books are concerned, that is Lean Six Sigma for services, Mikhail L. George, publisher McGraw-Hill, Six Sigma Demystified, a self-teaching guide, Paul Keller, by publisher again McGraw-Hill, Six Sigma Handbook, Thomas Pisdeck, publisher again McGraw-Hill, Six Sigma for the managers, Brugger, and this is also published by the McGraw-Hill. Now, as far as today's session is concerned, the today the learning will be the illustrate stepped evolution practices and background of the Lean Six Sigma management, to outline the key features of Lean Six Sigma and their integrations, to demonstrate elements, methodologies, and practical applications. We will let the utilization and practical applications of the Lean Six Sigma, and we are going to go with the some case exercise and MCQ based questions. As far as introduction to Lean Six Sigma is concerned, the idea of the Lean and Six Sigma are combined in the potent approach known as Lean Six Sigma, which helps organizations achieve process excellence, reduce waste, and boost overall performance. Lean focuses on getting rid of non-value added tasks, streamlining procedures, and increasing productivity, whereas Six Sigma seeks to reduce the defects and deviations to improve the quality of the products and processes. So the combination of these two techniques, businesses may optimize operations, provide not top-notch goods and services, and successfully meet the client demands. You can notice the diagram which is indicating the lean and Six Sigma equal to the lean Six Sigma. So lean means the creating the values for the customers by minimizing the waste. Six Sigma is reducing the defect by effectively solving the problems. So lean Six Sigma is accelerate the solving problems and improving the processes is faster and more efficient. What is lean? The lean refers to a collection of the principles and methods that focuses on the identification and elimination of the non-value added activities in any processes. James Womack and Daniel Rowe coined the term lean in their 1990 book, The Machine That Changed the World, MIT Press, to describe the manufacturing paradigm often referred to as the Toyota production system developed by the Toyota Motor Company based on the principles pioneered by the Henry Ford. We'll just talk about the building of a lean. Then it is basically foundation is based on the 5S and Kaizen, and which is having the pillars of the tech time and the main machine. This arrangement and supervisions, which also having the small pillars of the JIT and JIDOKA, on which the roof is of a quality and delivery times and the cost. These are the three major pillars of the roof. So this is basically a house of the lean, which we'll going to discuss in detail. And as far as APICS definitions of the lean manufacturing, lean production is concerned, a philosophy of the production that emphasizes the minimization of the amount of all the resources, including time, used in the various activities of the enterprise. It involves identifying and eliminating the non-value adding activities in design, production, supply chain management, and dealing with the customers. Employing team of multi-skilled workers at all levels of the organizations, in contrast to division of the level and labor or specialization. We'll just go with this diagram. In the first diagram, it is showing that optimistic that half glass is full. If it is the pessimistic, the half glass is empty. If if we are going with the lean practices, then why this glass is double of the size of the liquid which is going to be required. So, and another the setup of a machine, that if you are going with the standard NC machine, then the product variety will be low. If you are going to the flexible manufacturing system, then product variety will be the medium, and this speed of manufacturing will also be the medium. And if you are going for the transport line, then the speed will be the high and product variety will be low. So in such case of the where the transport lines are there, that lean practices are going to be the more suitable, where the this product variety will be the low. Six Sigma world class manufacturing is a data driven methodology for eliminating the defects. It drives out the towards the six standard deviation between the mean and the specifications. It improves the quality of the product, services, and the processes through robust design, that is parametric setting that reduces the variability due to the noise or assignable factors. Thus, improve the process capability. Six Sigma quality level means 3.4 defects per part million. And if we just go with this, the graphical representation, which is showing the 1 sigma is equal to a defect per million will be 6,992,000, and the percentage yield will be the 30% only. We'll go to the 2 sigma, then it is almost 308, 5382, 538. So it is the yield will be the 69%. If we'll go with the 3 sigma, the defect will be the 66,000 around, and 93 will be the yield. 4 sigma 6000 and yield will be the 99.3. 5 sigma 233, 99.9 will the yield. 6 sigma will be the 3.4 defects per million, and it is 99.9997. So we can see, as we are going with the 1 sigma to 6 sigma, it is variability is drastically reducing, defect per million it is drastically reducing. And with this diagram also we can see, this is the lower specification limit, upper specification limit. We are having this central mean value. Under the central mean value, the 6 sigma is being defined as a, if you are going with the 1 sigma, then our variability, this lower specification limit and upper specification limit in the 6 sigma, it is going to be beyond that. And 3 sigma, it is also going corresponding the beyond that. And if you're going with the 6 sigma, then it is within that level. So this is the how we are going the normal distribution curve, which is showing the your different levels of the limits along with the 6 sigma practices. Now, a management philosophy and the disciplined problem-solving methodology backed by the powerful statistical tool using a cross-functional team approach to reduce the service errors to the process defects to the 3.4 ppm opportunities or less. Three distinct level philosophy, variation reduction methodology. We are using the DMIC or DMADV or IDOV, optimizing the this design and methodology, and metric will be the 3.4 defect per million. The Six Sigma methodology using mainly the two approaches. One is the dynamic and one is the DMA/DV. If it is a existing system, then we are going with the dynamic, that is the define, measure, analyze, improve, control. If it is a new system designing, then we are going with the design, measure, analyze, and design and verify. These we are going to discuss in detail in the when we are going to those processes and the tools in the next sessions. VOC versus VOP, voice of customer and voice of process. The voice of process is independent of the voice of customer. As we can see in this normal distribution curve, the LSL and USL limits of your the voice of customers are very close. But if you are going with the voice of processes, then the defects are also going to be there beyond that. So it will be in the Six Sigma level. The defects will be 3.4 parts per million. So based on this, this VOC and VOP will be decided with the Six Sigma level. Impact of the Six Sigma, we have already discussed that the standard deviation, that is a measure of the variability, and Six Sigma is the quality improvement philosophy that focuses on the eliminating the defects through the reduction of the variation in the processes, and defect is the measurable outcome that is not within the acceptable specification range. So if we are going to see this graphical representation, then here with the target or the normal mean value, that if we are going to shift the mean value towards the LSL and between the target value, then our products which are going to produce that are going to be gone with the minimum limit of the value. Suppose there is a cement bag which you are going to go for the 50 kg and variation will be the plus minus 20 grams. Then if you are going with the target limit and LSL limit will be the your the limits, as the upper limit and the lower control limit, then the most of the bags which are going to be filled with that particular your cement bag will be having the lower content, lower weight will be the from the 50 kg, maybe the minus 10 gram, minus 15 gram. The most of the bags are going to be within that. So that is also not a very significant defect as far as the LSL and target limits are concerned, though we are within that range, but still it is not providing the good aspect as far as the provisions are concerned with that particular customer. So we are going to go with the controlling our this targets of the Six Sigma within the upper control limit on the within the lower control limit. By reducing the variability, we are improving the product with the before three. If we are going with the 3 sigma, then the processes becomes 3 standard deviation fit between the target and the specification. If we are going with the 6 sigma, then it is on the both side the customers that we are going to fit in the target. If we just talk about the what's goods enough, 99% with the 3.8 sigma and 99.999 good the 6 sigma. So the examples are 20,000 lost articles of the mail per hour, 7 articles lost per hour, unsafe drinking water for almost 15 minutes each day, 1 unsafe minute every 7 months, 5,000 incorrect surgical operations per week, 1.7 incorrect operations per week, 2 short or long landing daily at airport with 200 flights per day, 1 short or the long landing every 5 years, 2 lakhs wrong drugs prescription each year, 680 wrong prescriptions per year, no electricity for almost 7 hours each month, 1 hour without electricity every 34 years. So the example shows that how once we are going towards the Six Sigma level, then how drastically that the defects levels are going to be reduced very exponentially. And this is really going to be required by each organizations, whether it is a manufacturing or service organization. Not only organization point of view, but of course the customer satisfaction, customer delight, with that required your required quality and the required services, required specifications which are going to meeting in those particular your towards the level of the fitment as well as the level of the commitment with has been carried out with those particular your specifications. So not only with the number of customers whom we are satisfying, but we are arriving the corresponding to the almost nil level of the defect in even in the manufacturing as well as the supplying those items or the supplying the services to the customers. Six Sigma concept, if we'll just talk another way, the every human activity has the variability. However, how to meet those customer specifications within those particular limits, the in the acceptable range, this is a very significant target. If you are going parking the car in the garage has the variability. However, we are making those particular your this parking of the car within those particular the specified lines which we consider as your the customer's specifications. Defects will be beyond that. This will the customer's specification and our specifications will be the within that particular range of the car parking. That is the manufacturing range or that is the your servicing range. The goals of Lean Six Sigma, as far as the customer target is concerned, that we are going not beyond that particular your LSL and USL limits. That is your defect limit. We should not cross that. And similarly, if you are going with the shifting of LSL and USL towards the mean line, then it is also the prevent defects by centering the process. Lean is about moving the mean. Preventing the defect by reducing the variation. Six Sigma is about reducing the variation in the sigma or standard deviation. Meet the customer requirements. So this is the one aspect. This is another aspect. However, to meet that particular on a continuous target basis, the continuous customer satisfaction, so meeting the target that we are going to go, the our central line will be in between the LSL and USL. So Six Sigma focuses on the effectiveness, decreases defect rate, increasing the process yield. Lean focuses on the efficiency, reduces the average cycle time, reduces the excess inventory, improve the average response time. We'll just talk about the historical timeline of the lean overview. In 1930, the Ford system first assembled the line for Model T. People, machines, tooling were arranged in the continuous system, and the tools were developed as a your the SPC statistical process control tools for managing this. And towards going on 1930 onwards, 1950, the Toyota production system, also JIT, just-in-time manufacturing system, they have developed the small batches in a continuous flow. Using the techniques of or tools, the POCUOC, total quality management, SPC also, OE also, overall equipment effectiveness, and SMED, single minute exchange of the systems. And continuing further, in 1988, US companies adopted the TPS format, the machine that changed the word and the coin the term lean. Six Sigma was developed to remove the defects. Further moving in the 2000 years onwards, the lean manufacturing is commonplace. US Manufacturing Enterprise Act, the foundation for the smart manufacturing. Lean manufacturers expanded the lean enterprises. That is the tools has been developed. Now in today's scenario, the lean complemented by the lean digital, fourth industrial revolution, industry 4.0, for intelligent manufacturing, big data and AI, Internet of Things are being used in the manufacturing system and the supply system also. If we just talk about the history evolution in the Japan post World War II, rebuilding the of industry Japan, lack of market, domestic and the international, lack of cash to finance the big batch load size and the hold large inventory production method standard elsewhere, lack of machinery, lack of space to build the big factories loaded with the inventory and machinery, lacking in nature resources with the white with the built products, lack of jobs, lack of industrial manpower. If we'll just talk about the JIT and GPS, the history evolution in Japan, they built smaller factories with just required inventories, RM, WIP, and finished goods. Just required production quantities and the small lot size. It just required manpower, just required the investment, just required as per the market. Quick change for the setup to meet the market demand. Short throughput time, raw materials into the product, out time as per the tech time. Motivated manpower, emerging as a just-in-time practices. The lean overview historic timeline continue in 1800 early version is not a new concept. Early version of the method date back to the 1800 century when Whitney introduced the interchangeable parts to the manufacturing 10,000 muskets as a low price of rupees 13.40 for the US Army for the next 100 years. Manufacturers focused on the individual technologies moving the production from the one discrete process to another. These interchangeable parts are basically meeting the requirement of the different equipments which are going to be of a similar kind of model. Their challenges was what happened between the processes. They developed the time studies, standardized work, and the value stream charting that revealed the value add and non-value added steps. These were the beginning of the idea of the eliminating the waste. Coming to further, in 1930, the Ford system. The Ford system was introduced. The elements of the people machine tooling and the products were arranged in the continuous system to the manufacturing of the Model T automobile more efficiently. However, the Ford system lacked the flexibility and the collaboration with the frontline workers. And later, 1950, the Toyota production system. After the Second World War, the Japanese manufacturer leaders the Toyota production system using the statistical quality control practices and total quality management of Ishikawa, Edward Deming, and Joseph M. Juran, Toyota Motor Company, Teiichi Ono, and Shingo begins to incorporate these techniques into an approach called Toyota Production System or just in time. Shingo addresses setup and change over time, reducing the setup to minute, allowed the small batches in the almost continuous flow. The Toyota system has three objectives: design out Muri overburden, design out Mura inconsistency, eliminating the waste that is Muda. In other words, by focusing on the processes, design and flow, companies can create a system that create sustainably creates more value and less waste. Overall equipment effectiveness metric was also been developed in 1960 to evaluate the effectiveness of the manufacturing operations. Later in 1980, the term lean manufacturing was introduced to the Western world via the 1990 publication of the machine that changed the world. Since then, the lean principles has profoundly influenced manufacturing concept throughout the world. Lean has been frequently applied in factories to improve the operations, untangible production lines, and supply chain, and fix other manufacturing issues. Lean manufacturers have now become lean enterprises. Lean manufacturing stretches out from the factory premises to the stakeholders. So today, the lean manufacturing in the digital age gone the next step using the AI and the machine learning and the data analytics, making it more appropriate as far as the total sequence is concerned, and this variability reduction is concerned, using the continuous flow of the is concerned, and reducing the unwanted this non-value added task is concerned. So that's how it is been grown up now in the historic timeline of a lean as far as the industry up to the industry 4.0 is concerned. If we'll talk about the Six Sigma overview historic timeline, in 1980, the Bill Smith, a senior engineer at Motorola Corporation, created a Six Sigma. Six Sigma main objective was to reduce the defect and the variance in the production processes in order to improve the product quality to symbolize the goal of reaching a process that can produce no more defect 3.4 per million opportunities, which equals to almost 99.997 percentage, and name Six Sigma was adopted. Later, as a result of Jake Walls The CEO of General Electric implemented the Six Sigma as a crucial component of the company business strategy in 1990. Six Sigma received the widespread recognition and acceptance by applying the Six Sigma across the company. Welch guided the G to achieve considerable cost saving and the process improvements. Many other businesses adopted Six Sigma as a strategy to promote operational excellence and the quality improvement as a result of this success. Later, in 2005 onwards, the ICICI Bank starts implementing the Six Sigma methodology in the banking operations to improve customer services and operational efficiency. They utilize tools such as the DMIC, define, measure, analyze, improve the control, and the CTQ, critical to quality, analyze to identify and eliminate the defects in the processes related to the loan processing, customer onboarding, and the compliance resolutions. HSBC in 2007 adopted the Six Sigma methodology in its global banking and the financial services to enhance the processes efficiency and the risk management. They utilize tools such as the lean principles, value stream mapping, and the root cause analysis to streamline the operations, reducing the error and improving the customer satisfaction across various banking functions. ICICI Prudential Life in the same line also did that how to reduce that the six how to reduce the defects and the claims produced claims which are going to be proven, which are how it is going to be taken into consideration for customer benefits. So if we talk about both in combination, Lean Six Sigma timeline, Six Sigma on the upper side, it is showing that from 1990 to 1950, the Deming 14 point of a principles which are going to be how to reduce the defects in the manufacturing and the service sector organization, and going for the lean manufacturing from the Ford assembly lines to the Toyota production system, how it is being taken into consideration with the Gilbert management theory of the industrial engineering as well in between. We'll just continue. Then 1980, the Six Sigma adopted the SPC and the TQM approaches for to reduce the defects, and this lean practices have gone through the just-in-time methods and the technologies. In 1990, the lean manufacturing uses the change of the word the machine timing as well as the Lean Six Sigma practices. Along as the Motorola also introduces the Lean Six Sigma, and G Electric also adopted the Six Sigma practices, and this continue go with the Six Sigma and the Lean Six Sigma as a combination into the organizations. So APIC definitions of the JIT, if we just consider the primary elements of the just-in-time are to have only the required inventory whenever it is needed, to improve the quality to the zero defect, to reduce the lead time by reducing the setup time, queue lengths, and the load sizes, to incrementally revise the operations themselves, and to accomplish these things at medium cost. In the broad sense, it applies to all forms of the manufacturing job shop, process and repetitive, and many services industrial as well. Just go quickly for the MCQ based questions. What is the lean manufacturing primarily focus on? Maximizing the defects, minimizing the waste, increasing the cycle time, and expanding the inventory. So I think B is the correct answer, minimizing the waste. We often credited by popularizing the concept of the lean manufacturing. That is Henry Ford. It's the correct answer. When was the lean manufacturing approach first developed? 1950. Which of the following is the primary benefit of the lean manufacturing? Increased defects, reducing the lead time, higher inventory level, decreased customer satisfaction, reduced lead time. Six Sigma aims to achieve what level of the defect rates? It will be 3 defects per million opportunities. Which of the following is the benefit of the Six Sigma? Increased defect, decreased process stability, improved customer satisfaction, higher production cost. So improved customer satisfaction is the correct answer. Now coming to the what is the value proposition to the stakeholder in the Lean Six Sigma? So value proposition in the Lean Six Sigma is about delivering the maximum value to stakeholders by minimizing the waste and reducing the process variation. It aligns processes improvement directly with the stakeholders, customer, employees, suppliers, and the investors, perceiving is the valuable. Key characteristics of value proposition in the Lean Six Sigma, how basically it is being carried out. So first is the customer centric approach. So prioritizing the critical to quality characteristics based on the customer requirement. Example, Reliance Jio focuses on the network availability and the data speed as CTQ to enhance the user experiences. Waste elimination uses the lean principles to identify and eliminate the at waste, timber, transport, inventory, motion, waiting, overproduction, overprocessing, and defect and skill. Example, DMART minimizes the inventory waste by adopting a just-in-time system. Process variation reduction implements the Six Sigma dynamic, define, measure, analyze, improve the control methodology to reduce the defects and variation. Example, Ultratech Cement uses Six Sigma to standardize manufacturing processes and minimizing the variability. Aligning with the strategic goals, ensuring the processes improvement supports organizational goals like profitability, efficiency, and the customer satisfaction. Example, ITC aligns the lean initiative in its supply chain with its sustainability goal, quantifiable results, emphasizing measurable improvements such as increase the throughput, reduce the cycle time, and the cost savings. Example, HUL uses the Six Sigma projects to reduce defects per million opportunity in its product lines. Purpose of the value proposition in the Lean Six Sigma, enhancing the customer satisfaction, delivering the products and services that exceeds the customer expectations, optimizing the resources through the efficient processes that minimizes the waste, increase the profitability by reducing the cost associated with the defects and the inefficiency, sustain the competitive advantages by continuous improving and innovations in the processes, understanding the stakeholder needs in Lean Six Sigma, identifying internal and external stakeholders. Internal stakeholders will be the employees, required streamlining processes, training, and the involvement in the improvement of the projects. Management seeks the profitability, efficiency, and alignment with the strategic goals. Department needs the effective interdepartmental communication and the resource allocation. External stakeholders will the customer demand quality, time, delivery, and the value for the money. These will be the their needs. Suppliers expect the transport procurement processes and the long-term partnership. Regulators require compliances with the industry standard and the regulations. Investors seek financial stability and the growth through the efficient operations. Industry example, Amul engages the dairy farmers, external stakeholders by ensuring the fair pricing and efficient supply chain management to deliver the fresh products to the customers. Ola focuses on the driver partners as internal stakeholders by providing the timely payment and the transparent policy, enhancing the service reliability for the customers. Mapping stakeholders through the value stream. Value stream mapping is the visualization, the materials and the information required to deliver the product or the services to the customer. It helps identifying the non-value added activities and aligning them with the stakeholder needs. Steps to map the stakeholders to the value stream, identifying the key processes, determining the critical processes impacting the stakeholder directly. Example, nitrogen fertilizer manufacturing. The key process includes the production, procurement, production, and distribution. Define the value stream, map the end-to-end flow or the activity that add value for the stakeholders. Apply, for example, in petroleum refining, the value stream includes the crude oil refining, quality control, and the distribution. Classifying the activities value added directly benefits to the stakeholders, that is quality testing in the cement production. Non-value added waste resources without adding the stakeholders value. For example, excessive inventory in FMCG. Aligning with the stakeholders requirement, base the each process steps with the stakeholders expectations, quality, cost, delivery. For example, HUL aligns the packaging processes with the customer's expectation for eco-friendly and the defect-free products. We just also discuss one case scenario, understanding the stakeholder need in Lean Six Sigma for ITC, FMCG sector. ITC, leading FMCG company in India, aimed to enhance the customer satisfaction, reduces the operational cost, and improve the internal stakeholder engagement. The company implemented the Lean Six Sigma methodologies, focuses on customer needs, ensuring the products availability and the quality. Internal stakeholder need, streamlining the process to reduce the workload and the enhancing the efficiency. supplier need, improving the procurement efficiency and reducing the lead time. The matrices were the customer satisfaction score before the implementation, it was 75. After the implementation, 88. Improvement the plus 17%. These are the some hypothetical the data. Inventory holding cost, INR cost per year in crores, 120 crores. After implementation, it is 90 crores. So reduced by 25%. On time delivery, 82%, but after implementation 95%, so increased by 13%. Procurement lead time days, 25 days and 15 days, so it reduces by 40%. Internal error rate, it was initially 5%, now 2%, so it is reduced by the 60%. Analysis of the Lean Six Sigma impact. Customer satisfaction score improved by the 75 to 88% due to the enhanced product quality and availability. On time delivery increased from 82% to 95%, directly addressing the customer expectations. Internal stakeholders needs, inventory cost reduction cut down from INR 120 crores to INR 90 crores per year by implementing JIT and the reducing the excess stock. Internal error rate reduces from the 5% to the 2% by standardizing the processes and training. Employees supplier needs, procurement lead time reduces from the 25 to 15 days through the supplier collaboration and streamlined ordering processes. So if we'll just talk about the cost savings, INR 30 crores year from the inventory reduction and the error minimization, improved customer satisfaction plus 17% improved by the uh, meeting delivery and the quality expectations, enhancing efficiency, 40% reduction in the procurement lead time and the 60% reduction decrease in the internal errors. This case demonstrate how alignment in the Lean Six Sigma with the stakeholder needs to can significantly improve the cost efficiency, reliability, and the customer satisfaction for FMCG companies like IITC. Data entry, calculation, and analysis and recommendations also can be carried out. And the case scenario, the understanding the stakeholder need in the Lean Six Sigma. So if we can approach with the solution implemented demic, we are going to discuss in detail. However, the identifying the key pain point like inventory cost, delivery delay, and the internal error with respect to the ITC, the present case scenario. Measure the collected the baseline data on the cost, lead time, the error rates. Analyze, use fishbone diagrams and the Pareto analysis to identify the root cause such as excess stock and the process inefficiency. Improve implemented just-in-time standard workflows and the automated order processing. Control, establish the KPIs to monitor the cost, quality, and delivery performance. Value stream mapping, identify non-value added activities in the procurement and the production, reducing the waste and delays. Supplier collaborations, integrated suppliers into the ERP system for the real-time inventory and the order management. So recommendations for the future implement, predictive analysis. Use AI-based demand forecasting to optimize the inventory further to minimize the stock out. Employee training, expand the Lean Six Sigma training to more employees to sustain the process improvement. Digital transformation, invest in the IoT and automated system for the real-time monitoring of the production and the inventory. Now coming to the another next topic, as far as the culture of the Lean Six Sigma is concerned, how basically the culture of the Lean Six Sigma is needing to be developed into the organizations. It is not the overnight journey that we are going to develop that Lean Six Sigma practices into the organizations. The culture of Lean Six Sigma in the industries revolves around the continuous improvement, waste reduction, and focusing on the customer value. It integrates lean waste elimination principles with the Six Sigma, focus on the reducing the process variation and enhancing the quality. The key aspects of the Lean Six Sigma culture, which include customer-centric approach, prioritizing the internal external customer needs, data-driven decision making, using the data for problem solving and performance management, not on the basis of the these qualitative aspects, but based on the data. We are going to go with those analysis and reducing the applying the problem solving methods for improving the performance. Employee empowerment, training and involvement of the employees at the all levels in improving their initiatives. Standardization and continuous improvement, establishing the standard and focusing on incremental improvement rather than the drastic and radical change. Leadership commitment, top management activities, uh, and their participation in those particular small activities which are going to be aligned with the Six Sigma and Lean Six Sigma practices, principles, really to be leading from the leadership commitment. Description focuses on the understanding the delivery, what customer value most. Tools like voice of the customer and the net promoter score helps capturing the customer feedback and align the processes to meet the expectation. For example, FMCG industry problem is snack manufacturing receive complaints about the freshness data. Customer survey showed 20% dissatisfaction due to the expiration of the product on the shelves. Solution implementing a just-in-time system to reduce the shelf time, reduce the expiration product by the 30%, implement system, integrate the real-time inventory tracking with the retail partners. Description again, the data-driven decision making, utilizing the metric and analytical analytics to guide the decision, reduce the variability, and enhancing the processes control. Common tools include the control charts, Pareto charts, analysis, root cause analysis. Case example, service industry problem, a telecom company faces the 15% monthly customer churn rate. Data Pareto analysis revealed the 60% of the complaints were due to the billing errors. Solution improved the billing software and introduced the error proofing techniques. Churn rate reduces 10% and implement the predictive analytics for the proactive customer retention for the future. Empowerment, encouraging the employee involvement in problem solving and decision making to leveraging the frontline insight. Techniques include Kaizen and sessions system. Case example, problem high defect rate in an assembly line. Data 30% of the defect were linked to the manual handling errors. Solution employee-led Kaizen event introduced the pictures and the standardized work. Defect rate reduces to the 4%. Improvement sessions establish a reward system for the process improvement ideas. Standardization and continuous improvement. Develop the standard operating procedures and continuously define them using the PDCA cycles. Case example, if we take in the FMCG industry, suppose there is a problem of inconsistent packaging lead time. Data cycle time varies from 5 to 9 days. Solutions created standard work procedures and reduce the lead time to the 4 to 6 days. Improvement sessions conduct regular audits and the learn training for the operators. Leadership commitment. The description ensures the leadership drives culture change by providing resources and aligning the goal with the Lean Six Sigma principles. We'll just take the service industry example. Suppose there is a problem of low employee engagement, 50% satisfaction score. Data survey shows that unclear strategy goal is a key issue. Solution leadership introduce the transparent KPIs and the quarterly town halls. Engagement score rose to the 70%. Improvement further how it could be carried out. Implement a leadership training program on the Lean Six Sigma principles. Again, we'll go with the MCQ based questions. Which of the following is a benefit of the Lean Six Sigma? Increased defects, reduce the process speed, higher production cost efficiency, improved processing. So D is the correct answer. Which of the following is not a principle of lean? Define value, identify the value stream, ensure the quality at the source, establish the pool. So I think the C is the correct answer, ensure the quality at the source. What is the primary goal of the define phase in the dynamic process? Identifying the root cause of the problem, develop the solutions to improve, establish the project objective and the scope. So I think C is the correct answer. Which country is credited with the origin of JIT and TPS? I think it is Japan. Which of the following is not a waste category in the lean? Overproduction, wetting, transportation, inventory optimization. So inventory optimization is the not a waste categorization in the lean. Now coming to the principles of the Lean Six Sigma, if we'll just talk about what are the principles based on that, the Lean Six Sigma principles, Lean Six Sigma can be practiced in the industry. Then employee engagement and empowerment, that can be the first task. The customer focus, data-driven decision making, process optimization, continuous improvement, standardization, eliminating of the waste, and management support. So it starts with the management supports, the customer-centric approach, strategy, data-driven decision making, and the continuous improvement are the foundation of the Lean Six Sigma. Every Lean Six Sigma program is built around the needs and requirements of the customers, and data analysis, direct process improvement. The concept incorporates continuous improvement in order to foster the culture of the unrelevant percent of the excellence and the waste minimization. Customer focus, in order to build and deliver the product and services that add value, it essential to cooperate with the meet the customer needs and expectation. Businesses can align their operations with the customer requirement by adding actively and listening to the voice of the customers and adopting the customer feedback, which increases the customer satisfaction and their loyalty. The data-driven decision making, Lean Six Sigma has its foundation on the data, which is used to drive the decision making. Instead, them depending on the assumptions or gut feeling. Every improvement effort is supported by the objective data analysis. Organizations can find the source of the issue, quantifying the process effectiveness, and the take well-informed decisions by gathering and evaluating the necessary information. For the purpose of problem solving and the process optimization, statistical techniques and the methodological methodologies are used to verify accurately and validity. Changing the parameters for the cement process requirement data based analysis. Process optimization, Lean Six Sigma strives to improve the process to get rid of waste and inefficiencies. Workflows are made more efficient by identifying and eliminating non-value added processes through value stream mapping and the process analysis. The emphasis is on enhancing the process flow, cutting lead times, and attaining the operational efficiencies. Continuous improvement, Kaizen, which is Japanese means change for better, is a cornerstone of the Lean Six Sigma methodology. It promotes a culture of continuous improvement in which all the staff members actively look for the ways to improve the workflow and get rid of waste. Continuous improvement initiatives are iterative and continual, encouraging and attend attitude of the constant progress. Standardization, Lean Six Sigma requires the standardizing process to guarantee consistency and reproducibility of the findings based on the best practices discovered through the data analysis and the improvement activities. Standard work procedures are formed. Standardization improve the process stability by reducing the variability. Elimination of the waste, in the lean terminology, the waste or muda refers to any action that does not improve the final good or services. Lean Six Sigma helps the businesses becomes more productive and efficient by identifying and eliminating the waste, such as overproduction, waiting time, transportation, excess inventory, and the defect. Employee engagement and empowerment. Lean Six Sigma promotes involving employees at all levels in improvement projects. Employee engagement increases the likelihood that they will offer insightful sessions, accept changes, and take responsibility for the results. Employees who are equipped with the required knowledge and the resources can actively contribute to the success of the company. Management support, effective leadership, and the management support are essential for the adoption of the Lean Six Sigma. Executive and the leaders must actively support the processes, offer resources, and foster a culture of continuous improvement throughout the entire organization. JIT versus Lean, just-in-time manufacturing focuses on the business side of the improving the manufacturing processes by lowering the cost and reducing the time lags. Lean manufacturing places a focus on the customer value across all departments, including the manufacturing, production, marketing, and distribution. JIT can viewed as big JIT and the little JIT. Big JIT now often termed as the lean. Production is a philosophy of the operations management that seeks to eliminate the waste in all aspects of the firm. production activities, human relation, vendor relations, technology, and the management of the materials and innovations. Benefits of the Lean Six Sigma, if we just talk, will be the sustainable competitive advantages, reducing the defects and the errors, enhanced customer satisfaction, strategic alliance, increased profitability, data-driven decision making, culture transformation, increase employee morale, faster product process the cycle time, enhance the process effectiveness. Beside the reducing the defects and the waste, as far as the Lean Six Sigma, the main this objective is concerned, these are the different benefits over the Lean Six Sigma applications, which we'll discuss one by one. Organizations can gain many advantages through the Six Sigma, such as the higher process effectiveness, reduced errors and defects, improve the customer satisfaction, increase profitability, and better staff engagement. Lean Six Sigma assists firms in being competitive and evolving in a business environment that is constantly changing by encouraging a culture of continuous improvement and data-driven decision making. Enhanced process effectiveness, that is the known value added activities and the waste in processes are discovered and eliminated using the Lean Six Sigma. Organizations can increase the process efficiency and the productivity by streamlining the workflow and decreasing the process variability. Reduce defects and errors, that is the Six Sigma data-driven methodology supports firms in the discovering the root cause of the errors and the defects in the processes. Organizations may considerably reduce the defects in the product, produce the goods and services of the superior reliability and quality by putting database solutions into the practices. And as customer satisfaction, Lean Six Sigma places a high priority on meeting the customer needs and the expectations. Organizations may increase the customer loyalty and the retention by matching the procedures with the customer needs and the providing the goods and the services that meets or exceeds the expectations. Increased profitability, Lean Six Sigma can result in the cost saving and greater profitability by reducing the waste, enhancing the process effectiveness, and improving the product quality. Organizations can maximize their resources and lower operational cost by avoiding the rework, scrap, and excess inventory. Data-driven decision making, Lean Six Sigma focuses on the data analysis and statistical techniques to make decisions, which is referred to as the data-driven decision making. These data-driven methodologies make sure that improvements are founded on the factual evidence, resulting in more successful and long-lasting customers and long-lasting consequences. Culture transformation, Lean Six Sigma implementation promotes a continuous improvement culture within the company. Employees are urged to take the initiative in the recognizing and resolving the issues, which results in the more empowered and engaged workforce. Increase employee morale. Employee experiences a sense of ownership and pride in their job when they take an active role in improvement activities. A higher level of job satisfaction and employee retention may result from this uh, model. Faster process cycle time. Lean Six Sigma can result in the faster cycle time by removing the waste and lowering the process bottleneck, allowing the firms to react to the customer request and the market changes more quickly. Sustainable competitive advantage. Lean Six Sigma enables the firms to continuously adopt and improve, giving them a sustainable competitive advantage in the market. Organizations stand out from their rivals by having a capacity to provide higher quality goods and service quickly. Strategic alignment. Lean Six Sigma projects frequently aligns with the strategic corporate objectives. Lean Six Sigma is a strategic instrument for company success because it guarantees that improvement actively and are closely tied to the organization's overall goal. If we'll just go through these few picks with those particular diagrams. Then what makes lean so promising in the service and manufacturing industry? A customer driven waste reduction techniques. It focuses on the examine the current processes or operations. It improves the efficiency by decreasing the process time or the cycle time. Products produces or services to the beat of the customer demand. Measuring impact on the time capacity and the customer satisfaction. Initiates organizational change by involving employees participation. The T1 setup reduction time. The four key principles involves are the external activities, internal activities, parallel activities, and streamlining the internal activities. The shift setup time approximately the 15 minutes, and in the formula F1 the car it is only the 8 seconds. One piece flow order entry before the open mail batch processes, calculate the batch total, the enter the batch, stake and hold, acknowledge order, and the file batch. Now, if one piece flow order entry, open the envelope, enter the order, acknowledge the order, and file the order. So how this we can reduce the total number of activities and the non-value-added activities to reduce their it can increase your the process effectiveness as well as the reduction in the cycle time. Initiating the Lean Six Sigma basic description, purpose, and the case example. Just going with the combination of the Lean Six Sigma by eliminating the waste and Six Sigma, focus on reducing variation to enhance the efficiency and the quality in process. Effective initiation of the Lean Six Sigma requires a structured approach, including the top management commitment, a company-wide vision, infrastructure, and the deploying, the planning, and the selecting the right people for the right project. So to implement this Lean Six Sigma and initiating the Lean Sigma practices and the principles into the organizations require habit and developing it from the top organizational structure. That they are also going to be committed to those particular Lean Six Sigma principles are going to be applying slowly to each area and wherever it is going to be required. So that's how it is going to be developed in with that initiation and to the whole of the organizations. So first start with the top management commitment basics, the active involvement and support of the senior leaders in adopting the Lean Six Sigma principles. This includes allocating the resources, setting strategic goals, and the fostering a culture of the continuous improvement. Ensures that Lean Six Sigma projects aligns with the strategic business goals and receive the adequate funding and supports. Case example, General Electric problem, high defects rates in manufacturing lead to increase the cost and the customer dissatisfaction. Action, CEO Jake Walls made Six Sigma a strategic priority, mandating that all managers undergo Six Sigma training. Outcome, achieved the cost saving of the over $10 billion in 5 years and significantly improved the customer satisfaction. Key insights, management visible commitment was crucial in motivating employees to embrace the methodology. Company wide vision basics, establishing a clear and shared vision that articulate why Lean Six Sigma is necessary and how it aligns with the company's long-term goal, provides a direction and the sense of purpose for all employees, ensuring that improvement efforts contribute to the common objectives. Company-wide vision, establishing a clear and shared vision that articulates why Lean Six Sigma is necessary and how it aligns with the company's long-term goals, provides a direction and the sense of purpose for all employees, ensuring that improvement efforts contribution to the common objectives. Problem for the 3M corporations, lack of coherence in process improvement efforts across the different units. Action, introduce the company-wide vision focused on the innovations and operational excellence through the Lean Six Sigma. Outcome, achieve the 30% reduction in manufacturing cost and improved product development cycles. Key insights, a clear vision, unified efforts across the department, enhancing the focus and the efficiency. infrastructure and development planning, establishing a robust framework and developing the Lean Six Sigma, including the training, resources, allocation, and defining the roles such as green belt, black belt, and the master black belt. Purpose ensuring the project are systematically managed and aligned with the business priorities. With the Motorola case example, inconsistent quality across the manufacturing sites created a structured Lean Six Sigma infrastructure, including the dedicated role and centralized project management office. Outcome achieved the 20-fold improvement in quality and the $17 billion saving. Key insights, effective development planning, and the role clarity were crucial for the sustainable improvement. Right people for the right project, the selecting the training and the right individuals for the Lean Six Sigma roles based on their skills, processes, knowledge, and the leadership potential. Purpose maximizing the process project success rates by ensuring that capable individuals lead the improvement initiatives. Case example, Bank of America, a long customer wait time and the high error rate in mortgage processing. Assign trained black belt and the green belt to the projects, focusing on the cycle time reduction and the error minimization. Outcome reduced mortgage processing time by 30% and the saved to $2 billion over 3 years. Key highlights, assigning the skilled and the trained individuals was the key to achieve to the target improvements. Summary of the key insights, the top management commitment drives the culture change and resource allocation. Company-wide vision aligns the whole improvement efforts what strategic goals are there. Infrastructure and development planning ensures the systematic and effective implementation. Right people for the right project ensures the likelihood the project success. So these are the basic four major thrust as far as the Lean Six Sigma practices, involvement and initiations are concerned in any of the organization. First it starts with the top management commitment, then company-wide vision that whatever the improvements are going to be there, it needs to be aligned with the strategic goals. Infrastructure development planning, also that whatever the infrastructure and development plan developments are going to be required with respect to that particular the commitment and the vision wherever this Lean Six Sigma practices are involved in some system in a process or in some of the activities, with respect to that the necessary development or necessary infrastructure as far as the machine requirement, some software requirement which are going to be taken into consideration. The skilled people with respect to that particular project are going to be trained first also and assigned those particular projects which definitely leads to a success. So this will be the normal procedures which the companies needs to adopt for as far as the Lean Six Sigma practices implementation and initiations are concerned. And of course there is a the particular the organization structure hierarchy is also there, that from the top management to the bottom management, it starts with the green belt, which are going to be at the last stage of the hierarchy. So that's how it is also going to be there. With those particular your the different type of your hierarchy structure as far as the Six Sigma practices are concerned. Their territory of the functionality and the job priority will also govern with that, and what their decision levels will also govern in respect of those particular hierarchy. And later, once it comes to the top management, the major decisions are going to be taken at the top management, which finally converts those particular your the ideas into a reality, and the significant outcome will also come once it is going to be applied to the that particular system and wherever it is going to be required or applied. We'll also talk about the basics of the lean. It The basic lean house will be there, where the building blocks of the standardization, stability, and JIT will also going to be part of that, based on the basics of the lean. What is the lean house? The lean house of the lean visualizes the structure of the lean where implemented when implemented in the organization, how it is going to be practiced with the foundation that we'll just discuss. It shows that the lean methods is a house whose components work together to achieve the desired goals. Just as the name suggests, House of the Lean anchors itself on the concept, strategy, and the principles of the lean manufacturing. So, sustainability, stability, and the standardization are the base as far as the basics of the lean or the lean house is concerned. Workflow maintenance of the equipment and the tools, visual information, and standardization work practices are the foremost first aspect as far as the foundation of the this lean is concerned. On the basis of that, if we'll just go ahead, then it starts with the pillars of those particular your the house, where the workflow layout, setup time, scheduling, small load sizing. It is one is the just in time leveling the production. That is the one aspect of the pillar. Another will the involvement in the is a elements will the teamwork, multifunctional workers, quality leadership, decentralized responsibilities, and motivation. Means as a teamwork and team effectiveness will be the involvement in those particular kind of respective the activities which are going to align simultaneously one after each other. Build in quality continuous improvement, the waste reduction, response to the defects, and error proofing in the continuous improvement. So if we'll consider these three pillars, then definitely it is leading to the highest quality, lowest cost, and the shortest lead time, which is the roof of that particular of the lean. So if we'll just talk about the what is the building blocks of the standardization, building blocks describes the intermediate steps that lead from the achievement of the one standard to the next. The process of the developing the building blocks helps teachers think about that what is likely to the come next in the instructions. A fundamental elements of the formative assessment practices. That is an example. The process of the identifying the building blocks includes the looking for the collections of the functions which requires the integration to draw the them together and the make them the different. As here we can see the building blocks will be the just-in-time leveled production, involvement, and build-in quality and the continuous improvement are the building blocks. What is the goal of the house of the lean? This pillar supports the roof, which signifies as the ultimate goal of the house of the lean, the value. Moving to the top, the goal of the lean is to deliver the maximum customer value in the shortest sustainable lead time, while providing the highest possible quality to the customer and the society. What is meant by Hajunka? The term Hajunka is the Japanese word was meaning the leveling. The project manager's Hajunka refers to the reducing the unevenness in the production and minimizing the overburden for your the project team instead of creating the project products in batches. Hajunka involves the processing orders according to the customer demands. So the what is the first level of the foundation of the lean houses? The foundation of the lean manufacturing houses, the stability. When applied to the production systems, this refers to the team stability, standardization of work, and continuously monitoring the strategy is the basis of the foundation. The stability is the first step that implementation in the foundation. It's the Toyota principle where you bring your process variability under the control. Stability is the prerequisite of to any process, improving their performances. It can be evaluated via the 4M of man, machine, material, and the method. If there is a instability in any of their the four categories, the process will not support lean methods and the continuous improvement. Once stability is achieved, it brings flexibility to the production changes. We go to the MCQ. Reliance Jio implemented automation in its service activation processes to reduce the customer onboarding time, which Lean Six Sigma tool would most effectively identified and eliminated bottleneck in the process. Fishbone diagram, value stream mapping, control charts, and POQ. I think B is the correct answer, value stream mapping. DMart focuses on efficient inventory turnover to offer the competitive pricing. Which lean principles does this strategy aligns with the most? I think it is overproduction, just in time, standardization, Kaizen. So just in time is the appropriate answer. Ultratech Cement reduces downtime in its manufacturing plant by standardizing the maintenance processes. In which dynamic phase Is standardization most likely implemented? Define phase, measure phase, and control phase in the improve. So control phase is the appropriate answer. Amul uses a robust supply chain to deliver the fresh product efficiently. Which lean waste is most relevant to the control in the perishable goods supply chain? Motion, wetness, inventory, and defects. So robust supply chain to deliver the fresh product efficiently. So inventory is the correct answer. HUL implemented a Six Sigma project to reduce the packaging defects in its personal care products. Which metric would be most appropriate to assess this project success? Net profit margin, customer satisfaction index, defect per million opportunities, market share. So C is the appropriate answer. Ola introduces the real-time analytics to match the supply and demand efficiently. Which Six Sigma principle is the best reflected by this approach? Reducing the process variation, focusing the customer requirement, and standardization and reducing the inventory. So I think B is the correct answer. In the petroleum industry, minimizing the downtime is the critical. Which Lean Six Sigma approach would be the most effective for preventing the unexpected equipment failure? So I think total productive maintenance. A nitrogen fertilizer manufacturing company reduces the waste by optimizing its chemical mixing process. Which lean waste category does this address the most? Transportation, overprocessing, motion, and inventory. Company reduces the waste by optimizing its chemical mixing process. Which lean waste category? So I think it is the overprocessing. A hospital reduces the patient wait time by streamlining the paperwork through the digital system. This action aligns the best by which the lean principles, the flow. Now, coming to the very important aspect as far as the variability is concerned, and to understand what type of the variability in the processes are there and which type of the variability we can control through the our different applications of the tools, especially the lean tools or lean practices, lean methods. So there is a process data variations can be have the natural variations on the random variations, and another will be the assignable and cause variations. If we'll talk about the natural variations, then the actual and expected variations in the process which are uncontrollable and comprising very small variation in the process operations, materials and the operating conditions which are mandatory or which are very natural having in those particular any system where it is a machine vibration, whether it is system vibration or where is a variation of the acceptance limit around. So assignable cause variations are the unexpected and can be attributed to the defect or fault or mistakes, delay, breakdown, accident, and are the shortages in the process, or it can be a result of some unique combinations of the factors coming together to actually improve the process. When assignable causes are present, your process is predictable. So if we'll just talk why to analyze process types of variation. Natural variations inherent in the process of the depends on the equipment and machinery engineering operations in the system. So it is a normal tool where variation all oil pressure of the machine, top up of the coolant, working play between the slides. If we'll talk about the assignable variations, special causes identifiable and controllable or correctable. For example, includes the equipment out of adjustment, defective materials, change in the parts of the materials, broken machinery or the equipment, operators, fatigue or poor work methods, and the error due to the lack of the training. It will talk, just go through the this graphical representation on the horizontal axis. That is the variability is there. So this is there is a two zones. One is the green zone, another is the red zone. If those particular your the variations which are going beyond the green zone, that is your special cause variation, and this is signifies the lower control limit. If we'll just go on the green zone, there is a one is the upper control limit and another will be the lower control limit. So if we're going beyond those particular zones, the whatever the variations are going to be there, which are going to be significantly there, the 2 3 points are going to be 2 points on the lower control limit and 2 points in the upper control limit which are going beyond the green zone. So those are going to be the assignable variations, and wherever those particular the variations which are going to be there within the green zone, it is a natural variations. So the variations which are going beyond those the green zone, that are going to be assignable variations and which we can control by implementing some processes or some techniques or some tools and tools wherever it is going to be applied. So that's how it is going to be a this view to analyze whether it is a natural variation and assignable variation. Based on that, your and which type of your assignable variations, which type of technique it is going to be required for solving this, whether it is a machine variation, whether it is a main machine variation, whether it is a manual variation, whether it is some kind of another variation which are causing to the machine or not signifying with that machine, but it is causing to the machine. So those we are going to analyze, and type of those particular variations are very significantly addressed for the study, and assignable variations are taken into consideration for reducing them to the natural variations. What is control chart? Control chart is a graph used to study how the process changes over time. Data are plotted in the time order. A control chart always has a central line for that average and upper line for the upper control limit and lower line for the lower control limit. So this we can see there is a your measurement, and this is on the horizontal axis is the time. So we can see there is a central line, that is a blue line, which is a process average, and based on that measurement there is some variations are going to be there, and there is a dotted line which is showing the upper control and lower control limit as far as the this chart is concerned. Now once those the points which are going beyond those particular dotted red line, then it is either in the lower control limit zone or the upper control limit zone. So whatever the points which are going to be going in the upper control and lower control limit zone, beyond those particular your the limit values, then those particular your the points considered to be a assignable cause, and these are going to be analyzed based on the type and nature of the problems into the system. So control chart is a graph used to study how a process changes over time. Data are plotted in the time order. A control chart always has a central line for the average and the upper line for the upper control and the lower line for the lower control. How it is being the control chart were invented by the Walter A. Stewart working for the Whale Labs in 1920, and also known as the Stewart chart, or also known as the process behavior chart. Purpose is to separate from the natural cause and the assignable cause variations, and to assist in the predict or assignable cause. Statistical process control defined as in use statistical techniques to control a process or the production method. SPC tools and procedure can help the monitor process behavior, discover issues in the internal system to detect or predict probable causes and the find solutions for the production issues. Sustainable statistical process control is often used interchangeably with the statistical quality control. So these are the another bell-shaped curves where the particular items, whenever it is going to go with those particular bell-shaped curves, and the your upper control and lower control limit within those particular your zone, then this is you called it as a your natural variations. Whenever those variations are going beyond that particular limit, then it is we called as your assignable cause. This we already discussed APIC definition of the JIT. I'm not going to repeat that, but here just to understand the JIT, this approach will be coming in the later slides, which to improve the quality to the zero defect, to reduce the lead time by reducing the setup time and queue length and the load size, to incrementally revise the operations themselves. This also we have discussed. So elements of the JIT manufacturing: eliminating the waste and improving the production capacity, enforcing the problem solving and continuous improvement. People make JIT work: total quality management, parallel processing, Kanban, production control, JIT purchasing, reducing the inventories, working towards the repetitive manufacturing, JIDOKA or the automation, with the human intelligence is the principle implemented in the lean manufacturing, where the machines automatically stores working upon the detecting an abnormal conditions and operators try fixing that defects to prevent the recurrence of those particular kind of issue. Waste operations, the downtime. So if we'll just talk about the downtime, waste from the products defects, waste from the overproduction, waste from the waiting time, non-utilized talent, the misuse of the resources, and the transportation waste, then inventory waste, the waste of the motion and efforts, over and the extra processing waste. So these are the total eight waste we can consider with the nomenclature of the downtime. So defects, overproduction, waiting, non-utilized talent, the transportation, inventory, motion, and extra processing. So waste elimination will be waste operations continue, transportation, wasted time, resources, and cost with the unnecessary movement of the material, tools, inventory, equipment, or the products, inventory waste from the excess products and the materials that can be produced, motion, wasted efforts due to the movement of the people, decrease. We can decrease work time between the workstations, waiting, wasted time spent waiting for the next processes, steps to occur, eliminate the bottleneck, overproduction, waste on the making more products than the customers demand, ensure the full production, over processing, waste due to the more work or the higher quality than the required. Too many workers are assigned, defects, waste from the products that fail to meet the customer expectation, reduce the scrap and the river. What companies employ lean manufacturing? The majority of the manufacturing now embrace the lean management. The 2010 compensation, the data manufacturing survey found that 69.7% of the manufacturing companies utilizing the lean manufacturing practices. Leading large enterprises companies, including Toyota, Honeywell, GE, Parker, Honeyfins, Illinois Tool Workers, Textrol, Intel, John Dries, and Nike, apply lean tools to improve the business's results. Most recently, GE published the Lean Way. Culp gives an update on the GE Lean transformation. Larry Culp, GE CEO, speaks about the lean being their strategy. It's how they will run their businesses and the crucial to grow. Small and medium-sized companies embraces lean methodologies to increase the customer satisfaction and the competitiveness in the global marketplace. Frequently, small businesses needs an effective production system that can addresses low volume and the high mix of the product. Lean allows manufacturers to identify waste and increase flexibility to ensure the and deliver of the right product at the correct cost. Lean provides a platform for the business rapid and sustainable future growth. What are the lean manufacturing tools? Lean tools provides the framework to solve the problems, measure performance, and analyze the optimized work processes while helping to manage people and change. Lean manufacturing tools are intended to help the drive out waste, simplify everything, create efficient flow, improve the quality control, and make the most of the factory resources. These are the over 50 different lean manufacturing tools that are can be implemented within the different businesses. So examples of the lean tools: 7 waste, SIG, big losses, 5 buys, POCIO, OE, TPM, SMDT, quality tools, Kaizen, PDCA, just in time continuous flow. These are the to create the flow, eliminate the waste, value stream mapping, bottleneck analysis, reduce the inventory, line balancing, Kanban, standardized work, and visual management. So lean tool and practices will just uh, divide into some particular aspects: the custom relationship, supplier quality, lean supply chain, just in time, human resources, workflow, workforce commitment, employee involvement, and quality circles are related. These tools are going to there. Manufacturing, the planning and control, labeling, scheduling, visual control, Kanban, and workforce engagement. If we talk about the process and equipment, cellular manufacturing, Six Sigma, Lean Six Sigma, continuous flow, waste identification, and POCYOK. VSM, TPM, Kaizen, SS, sorry, 5S and SMED. So Muda 7 West Lean. Muda within the lean is defined as an activity or the process that does not add value, gain visibility, and reduce the waste, waiting, idle time, excessive inventory, and the product defects. According to a study by PwC, 80 to 90% of the tasks is typically business processes are wasteful because they do not add any value to the customer. Seek big losses, the total predictive maintenance. TPM implemented the dependent on the understanding the reason for that productivity loss, the breakdown of your the machine and the processes, setup time, the plant downtime due to the changeovers, stoppages, short stoppages due to the minor issues, reduce the speed running at a less than the process design speed, defects the script or the defect parts are as a result of the process, setup script. These are the defective parts produced when they will be setting up the process. 5 by root cause analysis is the drive problem solving to the true root cause so that can be fixed. Asking why 5 times is the row will often help us to focus on the leading cause. Example of the lean tool continue. The oral equipment effectiveness is the measure used within the TPM, a composite measure of the overall availability, performance, and the quality. It measures the production productive time. Overall equipment effectiveness can be calculated by multiplying the following these three factors: availability, run time divided by the total plant production time, performance idle cycle time multiplied by the total count divided by the run time, quality the good time divided by the total count. So OE calculations rolls on the six big losses, the TPM into the one number that represents the effective operating rate for the piece of the equipment synchronized line. In the other words, the present of the time the equipment or the line is operating effectively or the valuable operating time. So it can calculate OE availability rate, performance rate, and the quality rate. Availability is the equipment failure, the breakdown, downtime. That is, we are going to calculate six big losses, setup, adjustment, performance, idle in the minor stoppages, reduce the speed of the operations, quality is a defect, process defects, scrap and repairs, and reduce the yield from the startup to the stable production. So OE will be the availability rate, performance rate, and the quality rate. So availability rate, performance rate, and the quality rate. Availability rate will the percentage of the time the machine is ready to produce, working correctly and not aimed changeover or the adjustment. So available time, schedule operating time minus downtime divided by the schedule operating time. TIP, we usually use the schedule operating time or the plant time, not a total time, because we might only plan to the run a machine for a half shift to meet the customer demand. This distinguishes efficiency from the effectiveness. Effectiveness relates to the customer demand, focuses solely on the efficiency on the individual piece of the equipment can lead to overproduction and excess inventory. So TIP will the schedule operating time usually does not include the time set aside for the plant maintenance of the brakes. Other downtime is considered as a loss, including setup, adjustment, and the breakdown. Performance rate ratio of the production compared to the standard actual output divided by the standard output. So TIP will be the rule of the thumb for standard output is to use the best output rate known to be the produced on the machine, regardless of the whether that is above or below design speed. If a machine consistently outperforming its design specs, your performance rate will exceed 100% and potentially availability problem, mask availability problems. On the other hand, if a machine has never achieved its design specs, using that as a standard is usually not helpful. The quality rate ratio of the sound output compared to the actual output, right first time output upon the actual output, TIP, any defective output that needs rework and repair or the scraping during the adjustment is not content as a quality output. So OE can be calculated based on the availability. So standard time will be based on that 480 hours minus 20 minutes. So it will be 460 minutes. Breakdown 20 minutes, setup time and adjustment 20 minutes, minor stoppage 20 minutes. So downtime 60 minutes. Available time, scheduled time minus downtime equal to 460 minus 60. So 400 will be the minutes will be the available time. So available time plus, sorry, divided by the scheduled time, 400 minutes divided by 460, so 87%. Similarly, the performance standard output and divided by the actual output. So performance rate will be the actual output divided by the standard output. 400 parts divided by the 800 parts, the 50%. Quality actual output produced, including the good or bad parts. 400 parts, defective parts, reject and scrap 8 parts. Good parts will be the 400 minus 8, 392. So quality rate will be the 392 good parts divided by 400 actual parts produced, so 98%. So if we'll just multiply all these three, it will give us the your OE 87% availability, 50% performance, and 98% quality. So 42.6% will be the OE. So OE is not the TPM, other misunderstanding. So OE is basically overall equipment effectiveness, either in the particular system or either in the particular equipment itself. So examples of OE lean continue. OE is the major most closely association with the TPM, but OE is not equivalent to the TPM as it's hard. TPM is not about the complex matrices, it's about the developing the capabilities of the people. Everyone is involved in pursuing the dual goal of the zero background and the zero defects production, maintenance, and engineering from an efficient partnership, and operators share ownership of the equipment. The new attitude and the behavior results in the culture shift that improves the moral drive and continuous improvement, target total asset reliability, and the support lean initiatives. TPM is a fundamental to achieve the lean flow, because the flow cannot happen without reliable equipment in the process. In turns, a good understanding of OE foster and effective TPM efforts. E1, use OE as an improvement metric. That is an aspect. Jim Lefford, senior mechanical engineer at Avogo Technologies, talk about the recently he put this away the trouble with the simple line performance metric, that is the does not tell that where you are losing. It may tell you that operating at 80%, 90% of the perfect, but you must look beyond the metrics to analyze your losses. So use the more OE as a concept, and with the line performance metric, with that we are going to, so the biggest losses will be the availability, equipment failure, setup adjustment, performance, idle, and the minor stoppages, reduce the speed of the operation, quality, the process defects, scrap and repair, and reduce the yield time. So these are the way that big losses can be taken into consideration based on the elements as far as the OE calculation is concerned. There will be another your MCQ exercise. Lean Six Sigma is the integration of the Agile and Lean technique. Lean and Six Sigma approaches. So Lean and Six Sigma approach is the correct answer. Dynamic is utilized for the designing the new product and process, improving the existing process. So improving the existing process is the correct answer. Six Sigma aims to reduce the defects to achieve the processes capabilities perfections of 99.997%. Value stream mapping is utilized to identify defects in the processes, optimizing the inventory management, analyzing customer feedback, identifying non-value added activities in the process. So identifying non-value added activities in the process, who is often credited with the popularize the concept of the lean manufacturing. So Henry Ford, sorry, Taichi Ono is the uh, popularize the person name, and the fifth is D. Yes, that is the correct answer. When was the lean manufacturing approaches first developed in 1950? In aligning a company-wide vision, which strategy is the most effective for ensuring the employee buy-in, the mandating the company-wise compliances without feedback, offering the training sessions and open forums for the discussion, communication. The first is the B, offering the training sessions and open forums for the discussion. Which approach best ensures that the right people are assigned to the right projects in the organization? So, skill assessment and aligning roles with the expertise. How can infrastructure planning supports strategic goals in the manufacturing company? By integrating the technology that enhance the production efficiency. Which of the following is the key characteristics of an effective company-wide vision? So it is the clarity and alignment with the long-term goals. Which of the following is the best support that aligns the human resource with the strategic projects? So competency mapping and the succession planning. Which approach best ensures that the right people are assigned to the right project in the organization? Skill assessment and the aligning the role resources. In the context of infrastructure planning, which strategy best suited for the operational agility? So it is investing the flexibility in flexibility and scalable technology solutions. Which of the following is the key characteristics of an effective company-wide vision? That is clarity and alignment with the long-term goals. Which type of service offers additional features or benefits beyond the core services? So it will be the reduced lead time. Six Sigma aims to achieve the what level of the defects rate? It will be the D answer is the correct. Which statistical tool frequently used for the Six Sigma for analyzing the process variation? That is the control charts. An example of processing the possession processing service is the car rental. Now method for the following exercise: Lean A is the a theory that tries to streamline the process and get rid of the non-value added activities. Six Sigma will be the method process improvement that puts a strong emphasis on the minimizing the defects and variation. Demic will be the systematic approach for problem solving utilizing the Lean Six Sigma projects. Waste will be a set of principles, the tools for finding and eliminating the process inefficiencies. Continuous improvement will be the a continual initiative to incrementally enhance the process. Green belt will be the assisting with the data analysis and improving improvement efforts is a role in Lean Six Sigma project team. So with this session outcome, we understand that to illustrate the background of the Lean Six Sigma and integrating the Lean Six Sigma management, to outline the key features and the principles of Lean Six Sigma management, to define the types of the services industries and their characteristics, to demonstrate the economy contributors by the service sector, to exercise cases and the MCQ based questions. These are the some references I have taken from the online case studies. And thanks a lot with this.
Sir, good evening. Vinayak here.
Hello.
Hello, sir. Good evening.
Yeah. Yeah. Good evening. Good evening. Hello.
Hello, can you hear me, sir?
Yeah. Yes. Yes. Yes.
Sir, thank you. Thank you for the class. I just wanted to know, we have not received the book for this subject. I'm not
Yeah.
able
Yeah.
to
I
find
have
it
in the
in the.
beginning. I have discussed which is available in the this PPT deck. There are four
Okay,
books. Yeah.
okay. But anything from the symbiosis, like for the other subject, we got the books in the portal model.
So actually, from the Symbiosis distance online, you are going to receive this PPT deck and the this whole this video also.
Okay, only the this PPT and video will be available, or
Yeah,
there will be a
PPT
book
will
as well.
be. I will just deliver it maybe today or tomorrow. So I think in next couple of days you will receive. It is very
Okay.
descriptive with the different examples also. If you must gone through it.
Yes, yes. No, I just wanted to understand because for the other subjects we are getting the books. So for this
Yeah,
subject,
yeah. Okay, okay,
do
okay, okay. So yeah, okay. I understand. There is a SLM for
ah
this also. that was not developed by me, but it is already been available. So you can just talk to the Alvin sir. He will provide you the SLM also. But
No, I
maybe
got
the
through. I gone through
SLM
the
will have
SLM, sir.
a small content rather than the whatever we discussed in the PPT through the whole deck
Okay,
of the
okay,
PPT and the subsequent sessions we are going to discuss in detail. So that is available of course, and that you can definitely approach also.
okay, sir. Okay, because in the morning I checked in SLM, there is no book available.
No,
So
you can
maybe
please talk to, yeah, please talk to the Alvin sir. Basically,
okay, I will
that book
speak to
is
her.
not developed by me, so it is not available with me. Otherwise, I could have been provided.
Okay, okay, sir. I will check with them. Not a problem. And I will refer
Okay,
the this
thank you.
PPT, sir. Thank you.
Yeah, yeah, yes, yes.
Okay, sir. Have a good day.
Okay, okay, good. So we will end the session now.
Okay, okay, sir. Yeah.
Yeah.